Nuclear power sounds almost futuristic. Massive energy from something incredibly small. Just a tiny amount of uranium can power entire cities. But here's the part most people never think about. Before uranium can power anything, it has to go through one of the most tightly controlled industrial processes on Earth. Because the uranium that comes out of the ground usually isn't usable for most nuclear reactors. It has to be changed first. And that process is called uranium enrichment. Now here's the strange part. Enrichment doesn't mean adding something to uranium. Scientists are actually trying to separate two versions of uranium that are almost identical. And that's what makes the process so difficult. The two important forms are uranium-238 and uranium-235. Chemically, they behave almost the same. But uranium-235 is the valuable one, because it can sustain the nuclear chain reactions needed to generate power. The problem is, natural uranium is mostly uranium-238, more than 99%, and the useful uranium-235 makes up less than 1%. So scientists have to separate them. But the only meaningful difference between them is mass. Uranium-238 is just slightly heavier, and that tiny difference changes everything. First, uranium ore is mined from the ground. Then it's processed into a concentrated powder called yellowcake. After that, it's turned into a gas called uranium hexafluoride. And this is where things become extremely technical. The gas is fed into machines called centrifuges. These machines spin unbelievably fast, sometimes over 50,000 revolutions per minute. Inside the centrifuge, the heavier uranium-238 moves outward slightly more strongly, while the lighter uranium-235 stays slightly closer to the center. But the difference is tiny. So one centrifuge barely enriches the uranium, which means the process has to be repeated again and again. Thousands of centrifuges connected together in massive systems, slowly increasing the concentration of uranium-235 step by step. And this is where things become dangerous, because enriched uranium exists on a spectrum. Low-enriched uranium is used for nuclear power plants. But if enrichment continues far enough, you eventually reach weapons-grade uranium. That's why uranium enrichment is one of the most politically sensitive technologies on Earth. Because the same process used for nuclear energy can also move toward nuclear weapons. Now here's something movies usually get wrong. The danger isn't normally a giant nuclear explosion. The real risks are radiation, toxic chemicals, and extreme engineering failures. Because uranium hexafluoride gas itself is highly hazardous, and the centrifuges must remain perfectly balanced while spinning at enormous speeds. Even a small failure can destroy entire sections of machinery. That's also why only a small number of countries can enrich uranium at large scale. It requires advanced engineering, massive infrastructure, and years of scientific expertise. But despite all the complexity and danger, countries continue doing it because the energy output is enormous. A tiny uranium fuel pellet can contain as much energy as tons of coal. And that's what makes uranium enrichment so fascinating. Behind the electricity powering entire cities are machines spinning faster than jet engines, separating atoms based on microscopic differences, in one of the most delicate and carefully monitored processes humanity has ever created.